अस्सलाम वालेकुम डियर स्टूडेंट्स। इस लेक्चर के अंदर हम डिस्कस करेंगे कि मैग्नेटिक मटेरियल्स की कितनी टाइप्स होती हैं। बेसिक टाइप्स को हम डिस्कस करेंगे। तो बेसिकली ये टाइप्स बनाई गई हैं मटेरियल्स को देखते हुए कि उनका एक्सटर्नल मैग्नेटिक फील्ड के साथ रिस्पॉन्स क्या है। व्हाट इज़ द रिस्पॉन्स टू द एक्सटर्नल मैग्नेटिक फील्ड। सो इनको इस रिस्पॉन्स की बेस पे हमने तीन कैटेगरीज में डिफाइन किया है। वन इज़ डायमैग्नेटिक, सेकंड इज़ पैरामैग्नेटिक एंड द थर्ड इज़ फेरो। जो फर्स्ट टू टाइप्स हैं हमारे पास, वी हैव डायमैग्नेटिक एंड पैरामैग्नेटिक। इनको हम नॉर्मली नॉन मैग्नेटिक मटेरियल्स कहते हैं बिकॉज इनका जो रिस्पॉन्स टूवर्ड्स एन एक्सटर्नली अप्लाइड मैग्नेटिक फील्ड है वो बहुत ही नॉर्मल है या वेरी लो है, or we can say that they exhibit a very extremely weak response to an external magnetic field। जबकि फेरोमैग्नेटिक मटेरियल्स जो हैं इनको हम जो है डाय और पैरा को हम कहेंगे नॉन मैग्नेटिक, वाइल फेरो मैग्नेटिक जो हैं they will be called as magnetic materials। Because ferromagnetic materials, they have very strong response to external magnetic field and have a wide variety of applications। So for magnetic materials जिसमें हमें मैग्नेटिज्म की रिक्वायरमेंट है उसमें हम फेरोमैग्नेटिक मटेरियल्स को यूज़ करते हैं, जिसको हम फेरोमैग्नेटिक मटेरियल्स में मोस्ट कॉमनली नोन एज फेराइट्स, जो कि एक सब क्लास है, सब क्लास ऑफ फेरो magnetic materials। There is another category which is known as anti-ferro. Nowadays, this category is more of scientific interest, and we will discuss it later। सबसे पहली जो टाइप है डायमैग्नेटिक मटेरियल्स। Diamagnetism is exhibited by all materials। जितने भी हमारे पास materials हैं they all exhibit diamagnetism। This is a weak repulsion to the external magnetic field due to no unpaired electrons। So we can understand it by schematic diagram when there is you can see when there is no externally applied magnetic field, the net magnetization is zero because the electrons are not exhibiting any magnetic movement due to that all electrons are paired। When externally field is applied, this will act in the opposite direction to the field। जो ये फील्ड स्ट्रेट हो रही है, इलेक्ट्रॉन जो लाइन कर रहे हैं ये अप्लाइड फील्ड के ऑपोजिट डायरेक्शन में लाइन करेंगे तो दे विल फील इन repulsion। So we will have a positive magnetization, sorry, negative magnetization। So that is why the susceptibility of the diamagnetic material is always negative, because diamagnetic materials always slightly repel the external magnetic field due to their opposite alignment towards the external magnetic materials। The next one are paramagnetism or paramagnetic materials which have their electrons or their magnetic movements are randomly aligned when there is no field applied। You can see here H is 0 while the movements are randomly aligned, but the overall magnetization will be zero, as will be cancelling out the magnetization of each other. So when the field is applied, they will try their best to align the direction of light field. As you can see, we have applied the field in this direction and they are trying to align themselves in the direction of field. So we will be having a positive magnetization, thus having a positive susceptibility in these materials. Paramagnetic materials, as you can see, these magnetic materials, thermal stability is very important, and this can change the susceptibility of these materials. So we write this equation: chi is equals to c by t, which is Curie-Weiss law, Curie law, which shows that in these materials the susceptibility depends upon the temperature. The third materials are ferromagnetic materials. They exhibit spontaneous magnetization. In the absence of magnetic field, they have some magnetization as they are aligned without the presence of an external magnetic field. So we have a strong internal magnetic field in these materials, and we will discuss this in our next lecture. That there are two theories. We can say a molecular field theory or a Weiss theory, which gave a best explanation of this whole phenomena, as we have to study the internal field plus external field to get the total field in these materials. See you later, guys. Allah Hafiz.